Hi, this is Binod Suman. This is the fourth video on Zookeeper. So before that, in last three videos, I have already explained what is the Zookeeper, where we should use the Zookeeper, what is the distributed system, what is the basic explanations on the internal architecture of the Zookeeper, and then we also discuss what is the client, what is the server, what is the assembler, right? The readers, throwers. And in the third video, we explained the J node, and I told you J node is a very magical things. This is a kind of the file system, so we can create the parent node and the child node, and everything we have done the hands-on, right? So from this video onwards, we are going to solve some very famous enterprises uh, problem statement or the use case, and this is the first problem statement we are going to solve. That is the how to implement distributed monitoring with the help of the Zookeeper. So let us understand the problem. What is it? So suppose you have the worker node or the any desktop or any laptop, right? So and then you want to monitor all these uh, three node, whether it is up or down and all those things, right? So what you will do, you will write the code. This is the another VM or the desktop, and then you will connect all the machines here, right? And you have to configure right here how many machines are there. One, what is the IP address? Two, what is the IP address? Three machine, what is the IP address, right? And then at the certain time of interval, you have to check the heartbeat of the each worker node with the help of the pull mechanism, right? So you will pull at the some kind of the interval, right? So suppose 2 seconds or 5 seconds you will pulling and get the information. So far so good, it will work. But why is the problem? Problem is that suppose you add one new node, then what you have to do? First thing you have to come and add in the configuration file. First change, whether this is the configuration file change or the database change or the code change. This is the one problem. Second, pulling is very expensive, right? Every 2 seconds or 1 second you have to pull that. And you know the most of time in 1 seconds, 80-90% time the system is not going to down, right? So then unnecessary you are doing the so many pullings, right? So, and the third important problem is that the single point of failure means if suppose this system itself get down, then your all monitoring will go the toss, right? So what is the solution for that? So what you will do, you will make this system, this the VM or the monitoring system, this monitoring system you want to become the distributed, right? Means you will have the many more machines in that. But again, problem is that how you communicate each machines, how the collaboration would be happen, which machine will store this configuration file, and who will watch which worker node, right? A lot of problem is there. And why you will do lot of problems if we have already the solutions, right? So what you will do, make one zookeeper, take one zookeeper cluster. So the moment you will take the zookeeper's cluster, you will various chance you will have the single point of failure. They have the mechanism to come out if something happen, right? So it will not happen, right? And but for your home practice, you can just take the one instance of the zookeeper and do all the exercise what I'm going to discuss here right now. And you subscribe this or the worker node. Whenever you are going to add the new worker node, they are going to subscribe here. That I will show you. And this node, that the node they are going to monitor, you can also subscribe the zookeeper, right? So whenever anything happen in any machine, if any new machine is going to join the zookeeper, you will get a notification from the zookeeper. So it will be the not the pull mechanism, it will be the push mechanism, right? So your this problem is solved. What is the problem here? This problem solved with the push technology. This distributed problem is solved because this is already the distributed, right? And this problem is also solved to configure the change. You no need to do anything. Whenever you add the new machine, just subscribe this Zookeeper and your work is done. But how this is working? What is the meaning of subscribing? What is the meaning of notification? Everything is done by the Z node. So here the concept is called the Z node. That in the third video I explain in very detail. So let me explain you how it is, how it works here. So yeah, so suppose this is your Z node. I am talking about this Z node is inside the Zookeeper, right? And what you have to do, you have to create one persistent node that I have already discussed in the third video. What is the persistent node and what is the when we should use the persistent node? This will be the persistent node, and this and give some name. No need to put any data. Just one name is sufficient. I will give the monitor or monitoring anything. Give the name, right? Then whenever new system is going to up, they will connect the Zookeeper and they will make one node here, and this node is the ephemeral node. Again, if suppose here new worker node, suppose this is the worker node 1, worker node 2. The moment he will come, he will create one ephemeral node. If any third Zookeeper is third worker node is coming, what they will do? They will create one ephemeral node. And you know what is the meaning of the ephemeral node. Thing is that suppose this is for the this node, and you can give any name. You give any name, or you can use the IP address. The name of the node would be the IP address of the worker node. Sorry, but we are doing all the practice in the one laptop, so all the worker node would be running on the same machine. So instead of the IP address, we can use the UUID, right? So once we this worker machine to connect, I will generate one UUID and give the name. So this machine name would be the U1, U2, U3. I will show you. Okay, and this is your J node that is inside the Zookeeper, and this client machine, right? This client machine is here. That is the your monitoring machine. They will subscribe this J node. The benefit of the subscribe is the J node. If anything change in this node, this is the parent, right? This is the parent node, and these are the child node, right? So anything change in this parent node, change means if any new child is created, any new child is deleted, that parent node will send one notification here, right? But how this thing happen? This thing happen with the help of the watches. So this is one of the important concept in the Zookeeper. So watcher is the listener of Zookeeper, and actually Zookeeper internally use the framework Kazoo, by which they have made the watcher. So watcher is the listener of Zookeeper, and when this listener trigger, so whenever any client connection disconnection happen, so if any client disconnection happen, any node is created. If you create any node is deleted, any node data is changed, or child node change, as I discussed here. So if you register, if you keep the watcher on this parent, if any activity happen in the child node, whether child node is adding or deleting, it will create the trigger. right? And keep in mind, trigger is the one shot operation. Means when you set one watch on any particular node, once it will activate one time, your watcher is complete finish. If something is happen next time, this watcher will not activated. So you have to make the watcher in such a way, in all the circumstances you should get the notification. That I will explain you. Now come to this the design here again. So what happen, the moment it will connect this monitoring machine, so what it will do, it will check the what is the number of children of parent node is the monitor. So he will get the number. He will get the number 1, 2, 3, right? Now, what happen? Suppose if any new node is created, any new worker node is created, no need to do anything. Suppose W4 is going to connect this distributed system. So what this W4 will do? They will create one worker node, right? They will create one worker node. Suppose U4. The moment you will add new worker node, this watcher will trigger and they will notify to the worker node that something is happened with the parent node, and that moment they will again want to know how many child of the parent, and earlier it was the 3, this time he will automatically come to know that 1 is added here. Another important thing, each node, whatever this is the parent node or child node, they keep many information. First, the ID of the child node. Second, what is the data of the child node. Third, how many children information if this node. What is the create time when this node has been created. What is the modified time. So all the things state is there for the each Z node. So what happen, when I will come to know, when I will get the notification from the parent node, he will say, hey client machine, I have some update, right? He will get the one pull mechanism here, right? Sorry, the push mechanism here. He will, this parent will push some information that something has been changed. Now you should take care what information you want. My job was that to inform you that something has been changed. So then he will come and check how many parents, how many children in that parent node, that they will call one method. That is called the callback, right? So callback happen when any change in the parent, and then these guys will go and check how many number of nodes in the parent, and they will check the state also. And the state they will come to know what is the create time. So by which this monitor can be able to show you that this W1 machine is logging from time 1, W2 or the W1 machine, W2 machine, W3 machine, right? So then you no need to do anything. Let any worker machine connect to the zookeeper. Automatically there will be one notification will be there, and they will call the one callback method, and from there everything is visible. So the main thing is funda that, or you know the important thing. I missed that important thing. This is the inferior node, and you know the meaning of inferior node. The moment W1 is disconnected, automatically zookeeper will disconnect. They will delete. Right? The moment worker node is disconnected, zookeeper will delete any inferior node created by the W1. And the moment this will create, they will do the trigger. So step 1, what is the step 1 happen? Worker node deleted, right? Worker node down. Step 2, if a mirror node deleted. Step 3, watcher trigger. Step 4, callback method of monitoring system activated. This is the 4 step by which your all the logic would be work. Right? So let me see everything through the code, then we might be get the better understanding what is happening there. Okay, let us go to the laptop. Thank you very much. So let us start the code. So whatever the code, I am going to show everything on my GitHub. So GitHub Vinod Suman, and if you go here the Zookeeper, and if in the Zookeeper all the codes are there, if you search here, this is the worker node and the Zookeeper monitor that I am going to show here. So let us start the Java code. What I am doing here, let me just show the code directly. So first you should have the one worker node, means worker node, that is your worker machine, right? W1, W2, W3. As we discussed, first we create one monitoring member node, right? So any name you can give, and I'm given the monitoring, right? So first you should create that, right? So that node must be there because this is the basic node. So I will start the application from the Zookeeper monitoring. So I showed the two machines, monitoring machines and the worker node. So if you see in the monitoring machines, what I have done, I have created one node, same name, monitoring name, member, I have given the member name, you can give any name. If this node is not exist, I am going to create it. And you can just put any data, or without data is also there, and the node type should be the persistent, right? This is a permanent node, right? The first step. Second step, you have to set the watcher. So if you see here, this is my monitoring machine, and when you creating the Zookeeper, we are also creating the watcher, right? And I have not specified which kind of watcher, means if any kind of the notification come, I have to take care. So I set the watcher, and by default one method name is process that you have to override. And in this notifications, means whenever I will get the notification something has been changed in the parent node, so then I will call this method start watching, means do something what you want because some change has been happened there, right? And then if you see here, so this is the first time, right? If anything happen, they will call this method must start watch. And start watch, this is very important line here. So what I am doing, I am creating the new watch on the get children. So I have already explained you, right? On the get children, you can subscribe one watch. So I subscribe one watch. So that's why I keep given here watch is equal to true. So what happens when I given the watch is equal to true? What are the callback method? This watch is on this object, and this object I am creating here, and in this object this watcher is there. So what happens? Anything when we happen, it will call this process method, and this will call the start watch. It will not the deadlock, because as I explained you, this is one shot operation. Once it will trigger, you will got these things, that's okay, then done. Again the next time it happen, because you have again make the listener here, so this is for the next time, right? First time you call it here, you already came in this method, and advance you set the watcher here. In this watcher, what are we going to do that? First I will check how many children are there, right? And then if I will say that I want to take the state, right? I explain you each node has the state, create time, modification time, and all those things. In state, I'm catching the set time. So I can show you this children since how long is active. So arrive since one. Right? So I hope this code is very easy code, simple. It's too much simple code, right? Very Pepsi code. No need to nothing is there much. So just I create one watch, one callback method. In the callback method, you have to display the children name and since when it is has been arrived, when it has been joined. And another thing is that you have to create the parent node if it is not created, and that is the persistent node. Now come to the worker node. What they will do? They will do nothing. Simply, this is the main method. The moment this system will up, you will create one UUID, because IP address we are not going to use that. Otherwise, we could have used the IP address. And they will subscribe the Zookeeper. Subscribe means they will create the object, and this is the server, the Zookeeper server, right? And if you see here, the member node, means the parent node. Inside the parent node, we are going to create one child node. So I have already mentioned in the third video, right? So after this backslash, this is the child name, right? And child name is the UUID, right? And the important thing is that you see which kind of J node I am creating here. Ephemeral means the moment this machine be done, it is automatically deleted these things. I am not making the Zookeeper project. I am just keeping the thread saving for this bigger number. So this worker node would be arrived for particular time. That's why I have given that in the both. Right. Now let me execute that. Right. So for that, first you have to start the Zookeeper. Everything I have already explained that. So put the start method. So this is the start Zookeeper. I am going to start. Zookeeper started. And this is for the server side. If you want, you can you connect the server side. I will also explain. We will see later. Now come to the first machine, right? And everything I hope I have built. And now in this machine you run the monitor machine. So first we will run the monitor machine, and these are the way to run the monitor machine. So if you see, I have given the Zookeeper, right? So I gave the Windows. If you see here, Zookeeper monitor means I am running this code. So the moment it will running, they must have created the one parent node. Parent node is the monitoring. So come and check whether they have created the monitor or not. So I have made already the server here, client here. So if you do the ls1, you can see this node has been created. Earlier it was not there. So do one thing, just delete the monitoring. Right now it is not there, and again run this. So if you see, this node has been created. Now if you can see here, it was not there, right? If you see here, this node was not there. Now if you do ls, it is created, right? Monitoring. And now right now it is showing number of children is 0 because we have not started the any worker node. Now do one thing, create one worker node. So if you see here, I am running the worker node here. Did you notice something? Automatically this method call and is showing the number of children is 1, and this is the number of name of the children because this is UUID, and arrived since the today date and time, right? So today date is time the 2:46 something is showing here, because the moment I add the monitor. Do one thing, add one more monitor here. So the same, create one more node. Create one node means again run the same code, the worker node. Keep I here, right? You can see now the number of children is 2. Right? The way you will be creating more machines, it will create. Do one thing. So let me create another one. Right? So now the copy paste same. I creating one. Now you keep your watch here, right? Here. Now it is added. Now it is showing the 3 machines because 1, 2, 3 machines are running, and you can see how the machines. This machine started from 226. This 227, this 227, 35, 7. Do one thing, now delete one machine. So let me delete the second one or the first one. So I just control C and see here something is changing. Now it is saying the number of children 2. Automatically they will say that one node has been deleted, right? If you delete the third one or the first one, the second one, control C, see here, automatically it will trigger. It will say the number of nodes is 1. The moment you again add the new node, it will show the children number of 2, right? Now it is showing the 2. So all the magic with the J node means on the monitoring we create one parent node here, and from the worker node we are just creating one child node. The logic is here, and worker node is the inferior node. This is all about the code. You can get all the code what I showed in the starting. So everything, all the code is here, worker node, and the child node is there. Use it, right? This is my GitHub, or the same code I have executed. Thank you very much for this video.